All right, guys, it's time for our continuation of our guarantee standard EE8, and today we're going to be going through solving systems of equations with graphing. All right, so let's look at our learning objective and concept. All right, so our learning objective is, again, systems of equations. We're going to be solving them, and in particular, we're going to be solving them with graphing. So we're going to find the solution by graphing them. Now, just as a reminder, what a system of equation is, a system of equation, are you kidding me? Let's do that again. All right, so our learning objective is we will solve systems of equations with graphing. And when we are solving the systems of equations, that just means we're going to be looking for the one point that satisfies both equations. And again, we're going to be doing it with graphing in this lesson. So we're going to put the linear equations on a coordinate plane and find that solution. So let's actually look at our concept. What is a system of linear equations? Well, a system of linear equations is whenever we have two or more equations. Now, these equations need to have the same variables, and we have to think about them together as a unit. So these two equations go together, and we kind of keep them together. Now, when we have a system of equations, we're usually looking for the solution to that system of equations. So here you see it says a solution to a system of linear equations is the ordered pair that satisfies both equations. Now, ordered pair that satisfies both equations, what that means is there's one point that might satisfy or make both equations be true. Now, when we're graphing systems of equations, we typically find that point by looking for the point of intersection between the two lines. So if you look at this example here, you'll see that I have two lines. I've got an equation that is this blue line, and I've got an equation that is this red line. And what I'm looking for, if I'm trying to find the solution, is what is the point that both of these lines share? And so here you can see that these two lines cross right here, meaning that that point is the solution. Now, when I said that it satisfies both equations, here you can see if I take that point, 1, -2, and -2, 1, and I substitute it into the blue equation, it makes it true. It satisfies it. Same thing with the red equation. If I take that point, -2, 1, substitute it into the red equation, it satisfies that one. It makes that one true. So when I say it makes it true, it means 1 = 1. That's a true statement, and 1 = 1 here. That's a true statement. That point satisfies the equations. It makes them be true. Now, let's also talk real quick. What about if we can't solve a system of equations? What if there is no point of intersection? That would be this, no solution. No solution is when the lines are parallel, they never cross. We also could have something called infinite solutions. We don't talk about them as often, but that's when we have two of the same equation that they share all of the same solutions. So when we are talking about systems of equations, we're talking about two equations, and we're thinking about them together as a unit. And when we are solving them, we're looking for the point that satisfies both, meaning the point that makes them both be true. On a graph, we're looking for the point of intersection between the lines. Let's go to the skill. So here for the skill, I'm going to go through step 1, 2. All right, so let's go through these skill steps and see how do we find the point of intersection when we are solving systems of equations with graphing. So let's always begin by reading the equation. So to begin with, this problem is telling us how many solutions does this system of linear equations have? So how many solutions? Is it either 1, none, or infinite? And then it goes on to say, if it is one solution, write the solution as an ordered pair. So if they do intersect, what's that point of intersection? Right, now I know what to do. Let's go through the steps. Step 1, graph the first linear function using the slope and the intercept. So I'm going to use blue to graph this first equation. Now I'm going to identify the intercept and the slope. The intercept is always the number that's by itself. So I will label that with b is equal to +3. Now the slope is always the number that's next to the x variable. In that case, it is -1/2. So I have m equals -1/2. So let's now use the intercept 3 and the slope -1/2 to graph this linear function. I'm going to start at +3 on the y-axis. The intercept tells me to start on literally to add plus 3 to 0 to end up here on the y-axis. Slope of negative 1/2. It is change of y. Here you can see change of y over change of x. So I'm going to go down 1 over 2, negative 1 over 2, and put a point. I'm going to continue that pattern, negative 1 over 2, continue that pattern until I have as many points as possible. Now, whenever you're graphing systems of linear equations, you also want to do it going the opposite direction. So instead of going down 1, positive 2, I'm going to go backwards 2, up 1. So I can continue this pattern this way. Here is more points. And you can see when I use this constant rate of change, I just have more and more points on that line. So here, let me go ahead and do my best to graph this linear function right through all of those points. Here we have the first equation. Now let's go on to graph the second equation. Let's do this one in red. Again, identify the intercept and the slope. The intercept, negative 7. That is the number by itself. That literally tells me to start at 0 and subtract 7 from the y value. All the way down here, negative 7. That's my intercept. Then the slope is 2. Now, I got to pause here because what is the rise over run if there's only the number 2? Well, you said, that's not 2. You simply turn 2 into a fraction, 2 over 1. You can make any whole number into a fraction by making it over 1. So starting from my intercept at negative 7, I'm going to count positive 2, positive 1. Positive 2 for y, positive 1 for x. Positive 2 for y, positive 1 for x. And when I do it this last time here, I see that that is the point of intersection. That is what I'm really looking for. Now I'm going to add a few more points to help me graph my line. Let me graph the line through these points. That's about as good as I can do. And then let's go on to answer the question. How many solutions does this system of equations have? So here you can remember that it is one solution if the lines intersect. Well, when I look at the system of equations, they intersect. They have a point where they cross. So that means this system of equations has one solution. So I'm going to write one solution here. And then the last thing I'm going to do is, now, what is that one solution? What is that point of intersection? Well, we always write our points as x, y values. So let's find this point right here of intersection. The x value is 1, 2, 3, 4. So for x, I have 4. And for y, I have to count up 1. So it is positive 1. So this system of equations has one solution, and that one solution is at 4, 1. All right, thank you. Have a good day.